Okay, good evening. We are looking at indices and logarithm. Indices and logarithm. So when you look at indices, we are simply looking at a way of expressing a number in a particular form. See, if you have products of a repetitive number, 2 times 2 times 2 times 2 times 2, writing this number becomes a bit tedious. So indices helps you to write it as a number and then a superscript. So you count 1, 2, 3, 4, 5. There are 5 of them. That's 2 exponent 5. The 2 is the base and the 5 is the exponent or the index. Yeah, so you should know that by now. Um, the 5 is also called exponent, index, or power. Okay, so that is how we write a number. So if I write 2 over 3 exponent 3, you should know that I am looking at 2 out of 3 times 2 out of 3 times 2 out of 3. That is the basic idea of indices. Let's take the laws of indices. So the first law, which is the product law, if you have 2 exponent 2 times 2 exponent 3, but I did it 2 exponent 2 is 2 times 2. 2 exponent 2 is 2 times 3 times 2. So if I bring them together, 2, 1, 2, 3, 4, 5, 2 index 5. That is the result for multiplying 2 exponent 2 by 2 exponent 3. But in simple thing, the law says that once the bases are the same, you repeat one, then you add the exponent. And that will mean that you have 2 index 5 as your answer. So the first law is stating that if you have e exponent m times e exponent n, bases are the same, you repeat it, then you add the exponent m plus n. So that is the first law of indices, that is the product law of indices. Second law of indices has to do with the quotient law. Quotient law. With the quotient law, we are looking at, let's say, 5 exponent 3 over 5 exponent 2. Obviously, you know 5 exponent 3 is 5 times 5 times 5. 5 exponent 3 is 5 times 5. This 5 go up here, this 5 goes up here. Now answer is 5 exponent 20. But in simple things, once you are dividing and the bases are the same, keep the base, subtract your exponent, and that comes to the answer 5 exponent 1. So this is a exponent m dividing a exponent n. The answer should be a exponent m minus n. We subtract the exponents. That is the second law of indices. Third law of indices, which is the power law, also called the power law, means if you have 2 exponent 3 all exponent 4, means that your 2 exponent 3 is multiplying itself for 4 times. So if that is going to happen, you keep the base, you add 3 plus 3, 6 plus 3, 9 plus 3, 12. Once you are adding the same exponents, once you are adding the same exponent, what happens is that it's the same as 2 exponent 3 times 4, which is what? 12. So with this, A index M, O index M, that should be A index M N. Yeah, should multiply the exponents. Simple as that. Okay. Okay. So um, these are the three laws: the power law, the quotient law, the product law. That's how I've indicated. So let's proceed further. We can look at some properties. We can look at some properties of indices. These are the laws, the three basic laws of indices. So we can let's look at the properties first, and look at how to use the laws and the properties combined. So let's take the first property. A exponent zero is one. So understand that any letter, any number raised to the power zero is one, except zero. Zero to the power zero is not one. It's indifferent. Apart from zero, any other letter or any other number raised to the power zero is one. It's a property of indices. So if you are solving any question and you get to the point where you have something to the power zero, understand that the answer is what? One. So that one should also be in your mind. So if I give you a question like 7 plus x exponent 0, means I'm asking you 7 plus 1, and that is what? 8. Second property of indices, we are looking at if you have products of two letters or to an exponent, you have to split A exponent and B exponent. And if I have 3 times 4 exponents 5, it means I'm looking at 3 exponents 5 times 4 exponents 5. Watch out, this is the product, it's not addition. If it's addition, you can't do it this way. If it's product, then you can go this way. So the product of two numbers to an exponent, you split the exponents to each of the numbers under discussion. So that is the second property that we looked at as well. We can also look at the third property, which is the negative index. If I have A exponent negative n, it should be the same as 1 over A exponent n. When you reciprocate this, it takes away the negative. So if I have 2 index negative 2, it is the same as 1 over 2 squared, which is 1 out of 4. 2 squared is 2 times 2. So there's a negative law also. Just turn upside down the thing, the negative leaves. That is the negative law. So all negative exponents are fractions in this class. So if I have 2 exponents, just as I discussed this, when give the 1 out of 4. Then let's look at power of quotient of two numbers. You can also split. So if you have A exponent n, A over B all exponent n like this. It should be A exponent n over B exponent n. If I have 3 out of 4 all squared, it should be 3 squared over 4 squared. So you see it works for both the quotient and then the product. If this product is split, if it's quotient, to give the exponent to each of the two numbers. It's very important. So we keep that property also in mind. Then we look at another property of indices, negative power of quotient of two numbers. So if I have A over B all to the power negative n, it should be B over E to the power n. So I turn upside down the quotient, the number divided by the number, then the negative leaves. So it's very important. So if I have 2 out of 3 to the power negative, and I've been asked to solve this, I can only solve this if I do it this way. 3 over 2 to the power 2. And that's 3 squared out of 2 squared. And that's 9 out of 4. If you want to investigate if you are right, you can use the quotient here by giving the negative 2 to each of them. Then you know 2 power negative 2 is 1 over 2 squared. And divided by 3 power and is also what 1 over 3 squared. 1 over 3 squared is 4, divided by 1 over 3 is 9. So division sign will change to that, then 10 outside in the second fraction. And it's again 9 out of 4. So you don't have to go through the stress. Just 10 upside down the number and then think of the negative. That is the next property too as well. And I'm rushing because these are just laws and properties. Then if you have fractional powers, their roots, if you have e to the power half, understand that it means you are looking at square root of a. If you have 4 to the power half, it means that I'm asking you for root of 4, which is what 2. To do the fractional powers are root. If you have e to the power 1/3, then that's cube root of a. And if you have e to the power 2/3, that means cube root of a all squared. So the top is always exponents, the down is always roots. If you have e to the power 3 and 4, it means that the 4 here is fourth root, so fourth root of a, and the 3 at the top there is all exponents. So we should take note of the fractional index of fractional powers. So these are the laws of indices. We are going to use them to solve questions. I'll stop my lesson here and give you questions so that if you really understand the laws and properties I've given you, you should be able to use that to solve the questions I've sent. So you solve them and give me feedback. Then it will inform me as to whether you understood them, because then we will know what to do from there. I wish you all the best. See you again when our next lesson. Bye-bye.